Don't? Okay. So, hello, ladies and gentlemen. I'm glad to see you here in Sydney. My name is Seva Weiner, Haas Telecom from Czech Republic, and with me my colleague Nikolai Smirnov from Hystax.
Hi, everyone.
Yeah. So today we discuss about how migration works from VMware to OpenStack. But before, few words about Haas Telecom. Haas Telecom is a service provider which provides services in own data centers in the heart of Europe, in Czech Republic. The IT infrastructure in place for migration is a virtual data center powered by OpenStack. The end users can manage their own infrastructure in the self-service portal. Object storage, based on enterprise architecture and open source solution, provides high reliability and good price per gigabyte. We also provide VDI as a service, DR, and backup as a service. Okay, so guys, who know about this portal? Please, hands up. Yeah, cool, everyone knows. So VMware is #1 hypervisor for enterprise and SMB in the world. But more and more customers are thinking about how to migrate their infrastructure from VMware to another platforms. So the main question is, why customers want to migrate their workloads from VMware? So the first issue, that VMware licenses and support are really expensive. Is it true, guys? Yeah? Okay, so especially expensive when users start to scale. The second point, that VMware offers SLA for different levels of support. You need a premium support if you want to fast response. And that makes the cost of VMware even more expensive. In addition, users face a big wait if you want to add new functionality or adopt a new integration methods. So it's a long period. Sometimes it's years for big enterprises to incorporate feature requests into production-ready software release. So that makes a real impediment for reliable scalability and time to market. So, and the last one, it can be business or political reasons. So, do you want to save your money? You need to migrate. So let's take a look to migration strategy. Migration is not simple. You have to buy a whole new platform and create a new architecture, resetting hosts and reconfiguring workloads. This slide shows you how many points you need to address. But if I say to you that you could migrate to OpenStack automatically with minimum downtime and address every little point in a few weeks, I will show you how we did that at Haas Telecom. So we have a customer in Italy whose company grows very quickly. They're using VMware in their data centers, and they use our IT infrastructure to host non-mission critical workloads. And they began evaluating our cloud for additional workloads. There is some more details about customer infrastructure. So they were using VMware vSphere for virtualization and had 152 VMs with different types of workloads. And this include high-performance workloads, transaction workloads, and database workloads, and enterprise workloads, it's them. So, and some of these workloads are mission-critical workloads that should working 24/7. And of course, challenges. So the first challenge, so we need to provide a high level of connectivity between Italy and the data center in Czech Republic. So we don't able to provide any little lapses for mission-critical apps. So we need to troubleshoot their application in real time, and customer had no experience with cloud. So we need to provide information how they manage their infrastructure. Okay, so how migration works, I'm turning it over to Nick Smirnov for more details. So Nick, please welcome.
Thank you very much. Hello, everyone. Thank you for joining us today, discussing such a complex and I hope interesting topic on migration from VMware to OpenStack. But before I jump to more technical details and description of what we did and how we did for this customer, let me give a quick intro of myself and Hystax as a company. So my name is Smirnov, CEO and co-founder of Hystax, where we do disaster recovery and migration solutions to OpenStack. So for the last several years, we spent a lot of time working at European and US-based high-profile startups doing disaster recovery and migration from VMware to AWS, to Zen, to KVM. And this is when we get familiar with OpenStack and we're pretty surprised with community and the successes OpenStack had, but we're a little bit disappointed with the fact that there is no straightforward way to migrate any types of workload to OpenStack. This is why we decided to found a company and focus our efforts on this. So yeah, this is what I've just mentioned. So, and for jumping back to this case, what Seva just mentioned, so we had a customer with VMware 6.0 with 14 EA6i hosts and both Linux and Windows workloads. So for Linux, it was Ubuntu, Red Hat. For Windows, it was primarily Windows 2012, but there was some Windows 2008. So and on Host Telecom side, we had OpenStack Newton and Ceph Joule to store VMware to store VM snapshots. And to provide secure data transfer between two sites, we created a VPN tunnel between these locations. So migration is not an easy thing. It poses a lot of challenges. So it's not just taking virtual disks and moving them to a new platform and boot machines on a new platform. So we need to understand and be smart in terms of hypervisors are different. They require a different set of drivers, different set of requirements. Also, when we schedule and think about migration, we need to be cautious and we need to be smart on downtime we can expect in case of migration and the whole duration of the migration, how many time we need to spend to do the actual migration. And also one of the blockers which prevents customers or companies even think about migration is lack of in-house expertise. So usually companies don't have any kind of expertise on understanding how to do a migration, so this is a huge blocker for them. So this customer, which we mentioned, is not an exception. So he had a strict number of requirements which we need to conform to do a migration and even to speak about this project. So first of all, we had to do migration in a background without impacting production in any case. So customer wanted to stay online, to stay in operational and productive while we did the migration, the process of migration. The second thing, if we require downtime, we had to be predictable in terms of that, and we need to provide customer with guarantees on what the downtime would be, and it had to fit into a maintenance window. The next one, as customer had sensitive data in his business application, the requirement was that we didn't have a chance and ability to install anything on VMs. So if we do replication, we had to do it externally. So nothing can be installed on VMs, on guest VMs itself. And the last but not least was the requirement that the whole process of migration should be predictable, should be controlled and managed. So before customer gives a thumbs up that, yeah, we can switch to a new platform, we can switch to a new site, he has to be 100% sure that everything is working correctly, we assign the right flavors to virtual machines and to different components, and everything is okay, so we can switch. So we started a thorough process of preparation to do a migration. So we worked in a close communication with technical team of the customer, like to understand the business application, to understand the dependencies between different components, drawing a topology of the business application, because as Seva mentioned, customer had databases, Exchange Server, SAP, and different kind of high-performance workloads. So we had to understand what we're migrating, what we need to move to a new location. So we recreated network topology, we recreated network infrastructure on Haas Telecom cloud, and we're ready to start the migration of computing part, the business application itself. So if we speak about migration of the computing part, it consists of 5 steps we need to accomplish to do a successful migration. First of all, we need to deploy agents, migration agents, which would externally replicate infrastructure, which would externally replicate a business application and send data to the OpenStack site, to another site where we would like to spin up our application. The second one, we need to configure these settings of replication, or how frequently we would like to do replicas or incrementals, or how long we would like to store our snapshots. I will tell about snapshots and why we do need, in the process of migration, why we do need snapshotting. I would tell it on a dedicated slide why we need it, how we do that. We need to create a migration plan. So the solution and expectation from customers is not just to migrate one VM. So it's a necessity to migrate a business application, a whole application consisting of different number of VMs. It can be hundreds, thousands. In our case, it was 152, as we mentioned. So we create a scenario or run book with a description of what we would like to migrate, what virtual machines we would like to migrate, what flavors we would like to assign, what network ports or IP addresses or MAC addresses need to be assigned to this machine. So all of this stuff is implemented and described in a migration plan. After that, we need to spend some time on doing some kind of proof of concept for ourselves and for the customer that we can migrate the solution, we can do test migration, we can spin up the application on OpenStack site and to run a set of tests against this migration just to be sure that everything is working fine, or we need to configure some settings to add more CPU or add more RAM to different kind of components. So we need to do some test migrations to be sure that everything is working smoothly and working fine. And finally, when we are sure we're okay, the customer is okay, we do a final sync of production site, and we switch to a new site. We switch. So the final sync, we need not to have any kind of data loss. So we, customer, and we want to do migration without any kind of data loss. So here, what we try to do is we do a final sync, and we switch to a new location. OK, so if we speak about data flow and how the actual migration works, it consists of 5 stages. These are replication, snapshot storaging, V2V transformation, or virtual-to-virtual transformation. It's orchestrated spinning up of a migration on OpenStack, and it's testing and configuration of this migration. So, but before I jump to the description in detail of each of these steps, let me give you a quick overview of the infrastructure we had and like what we had from a customer side, what we had from Haas Telecom side, just for you to have an understanding and clarity of what we did. So if you take a look at the left side, you can see the customer infrastructure. It was like VMware running a bunch of ESXi hosts with VMs on that, like controlled with vCenters. So classic VMware installation. On the right side, what we had in Haas Telecom data center was OpenStack Newton installation with Ceph Dual to store snapshots, to store deltas for all the customers' production, and our solution install. So about our solution, I will tell briefly in a while that it's like a set of Docker containers which just work as replicator, is orchestrated to spin up the infrastructure and things like that. So now let me give you a quick description of each of the steps and what we do on each of the steps, like on our way to replicate customers' production environment. So the first about replication part. So on replication sites, what we do, we deploy a small Linux Ubuntu VM on each of the ESXi hosts. If you remember, I mentioned that we had 14 ESXi hosts. So we deploy one virtual machine to each of the hosts. And what this VM does, it externally replicates all the machines around it. So it uses standard VMware change block tracking API, standard VMware API of taking snapshots. and it does retrieve deltas from these snapshots and send these deltas, these incrementals to an OpenStack site. So, and what we do, we just not only replicate the data, VM's data, but we also replicate metadata. So like CPU, RAM, network settings, things like that, which will help us later to do an orchestrated spinning up on an OpenStack site. So we want to replicate infrastructure, but we want to automate this process as much as possible. So and we retrieve this data from VMware as well. Okay, so a couple of words about snapshotting and how we store snapshots. So to store snapshots, we use object storage with S3-like API. It can be Ceph, it can be Swift. So in our case, it was Ceph Dual version. So, and we store these deltas or snapshots in a way that every delta we receive from the VMware side, from a customer side, is a separate object in an object storage, which gives us an opportunity to provide deduplication, not to require as much storage as all the customers' VMs would wait in megabytes or terabytes. So in our case, for this customer, we had 20 terabytes of data, and we could provide deduplication ratio of about 30%, about that. So, and why do we need snapshotting? Why do we need snapshots? Why we just don't copy or transform VMDKs or virtual disk to QCOW format or any kind of other format? So we do that to provide an ability to spin up test migrations or spin up a proof of concept at any time while our replication is still in progress. So we want replication to go and go and go while we'll be testing the migration. We'll be testing it on OpenStack side, but production is still running. It still generates some deltas. It generates some data, which we would like to replicate. At the same time, we would like to be able to spin up a test migration on OpenStack and test how it works. What we need to add, what we need to reconfigure, and things like that. So that's why we implemented some kind of snapshotting here. So for virtual-to-virtual transformation, it's a crucial part of the whole process of migrating data from VMware to OpenStack. So just to recall, in our case, we had a customer with ESX hypervisor, and we wanted to migrate to KVM, to OpenStack running with KVM. So to do that, we had to accomplish a set of actions. First of all, for Windows and Linux devices, we had to inject virt.io drivers to support a new platform. So to migrate from ESX to KVM, we had to install new drivers. The second thing we need to do, and this is very important here, we had to preserve the same network settings we had on ESX and to be the same network settings on KVM. Why it's important? Because the way ESX reads and apply network settings and the way KVM does that, these are two different ways. And if you just put one with the VM from VMware to KVM, when you boot it, you'll have network mismatch. So if you have more than one network adapter, the way KVM and the order in which KVM and ESX apply them is like two different orders. So to preserve network settings, we have to do some reconfiguration. We need to do some stuff here just to preserve network settings and to inject network adapters into the same virtual slots. This is what we do, and this is what we did here. And as I mentioned on a previous slide, so we store data in snapshots. Snapshots always are immutable, so we can't modify anything in customer data. And it's like a strong requirement not to modify anything in customer's data. So we do V2V on fly. When we boot machines, I'll tell about this in a while. So we create a SCSI disk to object storage and deltas, which we create and store in object storage, and we do V2V on fly when we boot machines on an OpenStack site. So how and what we do in terms of spinning up a test migration or a final migration on OpenStack. So to do that, we need to have some kind of way of describing of what we would like to spin up. We need to way to provide dependencies between machines because we want to be smart. We just don't want having 152 VMs. We don't want to just click one button and start all these VMs at once. We have dependencies between machines. We need to understand that there are machines with Active Directory, databases, SAPs, Exchange servers, and there are clients, so we need to be smart in terms of how we boot machines, what are dependencies between machines. To boot Active Directory first, databases first, and only when this process is done, we can go and boot like client machines and things like that. So to do that, we have migration plans. Migration plan is a scenario or runbook or cookbook. It's a JSON file which stores all the information about virtual machines we would like to spin up, like flavors, RAM CPU, ports, IP addresses, MAC addresses, either static or dynamic IP addresses, and also orchestration part, dependencies between machines. What to boot first, what to boot next, and things like that. So after that, this JSON file is converted to a heat template, and we use heat to do the orchestration part. But one thing I would like to note here, we are not using like a standard heat from any kind of installation or from any release of OpenStack. So we forked heat project. Why we did that? There are a couple of reasons. So first of all, we would like to be able to do migrations. So as it's a solution for migration, we would like to be able to do migration for OpenStack installations which don't have a heat project, which have like other projects but don't have heat. So we don't want to require customer to install heat project and to add heat project to any of the OpenStack installations we're migrating to. The next thing is because we want to be able to migrate not only to OpenStack, but also to other platforms. So we can use heat for that as well, just to provide orchestration and to add our own resources to heat. So that's why we just forked it and added our resources. So when we execute this heat template, we automatically run V2V process for each of the virtual machines. We create iSCSI disks to object storage where we store snapshots. And we also create regular Cinder volumes here. So for this customer, we had also a requirement that at some point of time, if we boot machines from iSCSI disks, so the whole business application is dependent on us. So all the data I/O is going through our iSCSI disk, and not all the customers are happy with that. So at some point in time when we are ready, they just want to exclude us from standard working on business application and work directly from and read data and write to Cinder volumes, regular Cinder volumes. So what we do here is we create empty Cinder volumes, and all the data generated by test migration or final migration when we do it is written directly to these Cinder volumes. And also in the background, what we do, we migrate data from object storage, our snapshots, to these regular Cinder volumes, to these regular Cinder block devices. So the purpose for that is that at some point in time, when we are 100% ready and all the data from object storage is already in Cinder volumes, we can just exclude our solution and to boot machines directly from these regular Cinder volumes. So our solution would be taken away. So that's why we just create regular Cinder volumes and create these iSCSI disks. So and the final step for us in the migration process is to do a couple of test migrations, be 100% sure that the migration is okay, so we can provide customer with a proof that yeah, it's okay. It's time for us to switch to a new location. So you can shut down your production on VMware. We do final sync just not to have any data loss. Do a final sync to OpenStack side, boot the whole business application on an OpenStack, and change DNS records to just switch customers from VMware to OpenStack. So to do that, we need to do a couple of test migrations. So usually and regularly for this customer, we had 2 migrations. Regularly, it's 2 to 3 migrations we need to do to be sure that everything is working fine. So what we do, we spin up a business application on OpenStack site, and we run a set of tests on this application. So it can be regular customers, set of tests he ran against his production, or stress test, load test, and things like that. So all the set of tests, you are okay that you don't have any data loss, all the components are working fine, there is no any kind of performance degradation in the process. So that's why we need this couple of test migration just to tune our business application, be sure that it's migrated correctly. So for this customer, we had 2. Usually, they are running for about from 3 days to 1 week, just to be sure. It depends on the size of the business application. For this customer, we had like 2 runs for about 5 days each. Okay, so that's basically it for the migration process. Let me give you some vision on what we would like to improve in the solution. So currently, we see 3 main points we would like to cover in the next months, next years on how to improve the solution. So currently, as I mentioned, when we boot business application from our iSCSI disks and we do this background migration from an object storage to regular Cinder block devices, at the point when we have like 100% of data in Cinder, regular Cinder volumes, we need to schedule and we need to plan another downtime, another maintenance window, just to switch and boot machines from another Cinder, from your regular Cinder driver. Just to exclude our solution, exclude booting from iSCSI disk and boot directly from block devices. So we focus right now to provide a way to do it automatically. When it's 100% in regular Cinder volume, just do a switch, and that's okay. So we are excluded, iSCSI disks are not used anymore, and data is written or read directly from a regular Cinder volumes. The next thing is to replicate and to recreate NSX, VMware NSX settings. So we want to provide a way to recreate load balancers, firewalls, VPN connections, and things like that. So currently, we don't support that, but we focus to do that. And the last thing we are currently focusing on is to provide a way to take consistent snapshots from KVM externally, to do it externally, not to require to install any guest agent on operating system, just to have a way. Because currently VMware has such a functionality, standard change block tracking API, or snapshotting, which VMware provides. So, but on KVM, we don't, or on OpenStack, we don't have such a functionality. So we are currently trying to figure out a way or investigating how we can implement that, how we can do that. So please stay tuned, and we'll update you on the results of this work. And finally, I would like to give you some technical details on how the solution works, what it requires, and what it is. So the solution is written in 2 languages. It's Python 3 and C++. So it is a set of Docker containers with different kind of services, and all the solution is orchestrated via Kubernetes. And we can actually work with any OpenStack distro starting from OpenStack Liberty. So that's basically it from my side. Thank you very much for your attention, and I would like to ask Seva to proceed.
Yeah, thanks, Nick. So, a few words about Haas Telecom Cloud. So, Haas Telecom Cloud, powered by OpenStack, 100 nodes installed with different configuration in each cloud. And we provide pay-as-you-go solution for our customers. So how it works with our customers in these projects. So first of all, we collect data about infrastructure, workloads, and the requirements for project. Second point is to collect and discuss about technical and general question of cooperation. After that, we launch a POC project and work on migration scenarios. After that, customer tests their workloads in our Haas Telecom Cloud, and if all goes fine, so we migrate all infrastructure to our cloud, and our cloud goes into the production. So, and in the all period, we provide training about how to use our cloud. So the success project was completed in 45 man-hours and 4 weeks. And this includes so all workload in the OpenStack cloud and include DR solution. About DR, we can share information in our booth. Second one, we provide a minimum downtime in the project. So we have only one maintenance window, about 3 hours. Customer sees higher performance than they had on VMware side. And customer has a self-service portal to manage their infrastructure. So thank you very much for your time and your attention. I would like to say we have a trial period for our cloud, so you can find your password in our booth. And we would like to show the demo how it works, and we can do this in our booth too. So we will wait you for show you the demo. Okay, so we will be appreciated to answer for your questions. So please ask your questions. So thank you very much again.
Thank you.
So questions?
Yeah.
Okay, one question.
How important was the hardware? So did you have problems with hardware compatibility or any of those sorts of things, low-level driver problems?
Yeah, okay, the question is, do we have any problems with hardware and compatibility of this in our site? So the answer is no, because we have real close working with customer and about architecture, how it works in the customer side. And we are the service provider, but before we have hosting provider. As a hosting provider, we know the little details about hardware. So the question is, no, we don't have any issues with hardware at this moment. So the next question is, yeah.
I think VMware has some special hierarchical architecture, like a data center or DRS or folder, so they can create some VM on some data center and folder, and put the VM under that folder. In OpenStack, I don't see those kind of organizing mechanisms.
Okay, so the question is, so in VMware, they have a DRS solution and vMotion solution. In the OpenStack, we don't have that. So our question, our answer is we create a custom solution for vMotion. It's like a functionality like as vMotion in our cloud. And we have a DRS. We use a Watcher project for DRS, and we write our scenarios how to balance the workload in our cloud as well. So we have this functionality how you have in the VMware side.
What about the folder? So they can create a folder on the data center, but how can you create a folder in the OpenStack side?
Could you please clarify what you mean? I don't understand you.
In vCenter, they can create the data center, right?
Okay.
Yeah, it's physical, right?
Yep.
Data center. But under that data center, they can create a folder. So they can put whatever name in the folder.
Pod name.
Folder, F-O-L-D-E-R.
Okay.
Yeah. So, but in OpenStack, I don't think we have those kind of logical folder.
So we have a host aggregation. So maybe this is the same one. Okay, so I think so. We can clarify your question offline, and we can discuss more about that. Okay, so any other questions? Okay, so thank you very much. Have a good day, and thank you for your attention. See you. Thank you.
Thank you.